Factorising non-monic quadratics, I'm going to show you two methods. You can pick your favourite. Now the first one is called the two pairs method, or at least I call it that. Now here's some instructions, and over here we're going to do an example following those instructions. Now it says if it's in this form, ax squared plus bx plus c. Now the a part won't be 1 in this case because we're looking at non-monic quadratics. If you've got a monic one, you can just draw up your brackets, put your x's in as your first terms, and away you go. But if this number in front of the x squared is something bigger than 1, something like 2 say, we can put it in this form. Now our first step is find factors of AC. So in other words, multiply this number and this number together and find factors of that add to b, which is this pronumeral here. So in this example, we need to multiply 2 by 2 to get 4, and then think of factors of 4 that add to 5. Now factors of 4, our only choices are 4 and 1 or 2 and 2. 2 and 2 don't add to 5, but 4 and 1 do. So it must be 4 and 1. All right, what do we do with the 4 and the 1? We break that middle term, the bx part, into those factors. So if I've got 5x here, and I know that the factors that I want is 4 and 1, I break my 5x's up into 4x's and 1x, or just x. Now it doesn't matter if you put the x first or the 4x first, it really doesn't make any difference, and you can do it both ways just to double check that. So we have the 4x and the x and the 2. So you can see that this term stayed the same, that term stayed the same, and my 5x is now just broken up into 2 parts. And I decided on those parts by finding the factors of 4 that added to 5. All right, next we need to just factorize each pair and tidy it up. So if I look at this pair first, let's get rid of that line, and factorize it as well as I possibly can, I'd be bringing a 2x out the front, and that's going to leave me with x plus 2 in there. And then if I factorize this part, they don't have any factors in common except 1. Everything has 1 as a factor. So I really have 1 outside of x plus 2. Now what you'll notice here, to be able to tidy up, this part and this part in the brackets need to be the same. So it's a pretty good way to check if you've done it right. When I make this first set here, I pretty much can put the same thing in the brackets there and then just see what needs to go out the front to make it right. At that point we say we've got 2x of these plus another 1 of them. So how many of these x plus 2's have we got? We have 2x plus 1, x plus 2's. And we're finished. Now the last thing we do is always check it. Use the FOIL method to double check that you get back to what you started with. 2x times x gives us our 2x squared. Our outsides is 4x. Our insides is x. So they add up to give us the 5x. And the lasts is 2. So we've got it right. Now if you get confused at this point here and you're wondering what I meant about making sure these brackets are the same, let me just give you a tiny rehash that might make a little bit more sense to you. If I ask you, say, what is 4 apples plus 3 apples, you'll have no trouble in saying that's 7 apples, right? And if I say what's 4 x's plus 3 x's, we know we're dealing with x's now. We have 7 of them. So if I say I've got 4, let's say, x plus 1's, and you give me another 3 x plus 1's, the x plus 1's are my apples, right? And the apples have to be the same for us to be able to add them. So I would have 7 x plus 1's, okay? So the way I remember it is make sure your apples are the same. So over here, these were my apples. I needed to make sure I had the same apples on the other side, if that makes sense, because then I can add up how many apples I've got. And we can make this more complicated here if we like. We could say, what's y, x plus 1's, plus 7x squared, x plus 1's. Well, what did you do here to get the 7? You just added these two numbers. So you just add these two, and you'd say I've got y plus 7x squared, x plus 1's. That got a little bit messy, but I think you can see where I'm going with that. So let's practice another one now, just to check that you've got this. Let's do 3x squared plus 4x plus 1. Now what was the first step? Multiply these two numbers together, we get 3, and then think of factors of 3 that add to 4. Well, there's only two factors. There's only one choice, 3 and 1. What do we do with that 3 and 1? We split our middle term up into 3x and x. So that gives us 3x here plus another x plus 1. All right, factorize this pair, factorize that pair. This question's quite a lot like the last one, isn't it? We've got x plus 1. Those are our apples. You can almost put those apples in and just double check. Yep, we've got one lot of them. So bringing it all together, 3x plus 1, x plus 1s. Then we check it. 3x squared, yes. 3x plus x, yes. 1, yes. So we've definitely got it. A slightly trickier example now. We've got 5 times negative 12 to make negative 60. So we need the factors of 60, knowing that 1 is going to be positive and 1 negative to make that negative. And they need to be able to add to 28 when we add and subtract them. So thinking of the factors of 60, again, using a nice sequential, you don't have to go very far before you say, hey, these two can make 28. I just need to do 30 minus 2. So that tells me I need to split up my 28x into 30x and minus 2x. Now, it doesn't make any difference which order you put them in. In fact, let's do this 2 ways just to prove it. So if I actually put the minus 2x first and then the 30x, we're still going to get the same answer. The working will just be a little bit different. So now I've got to factorize these two. They've got 5x in common, so I can bring that out the front of some brackets, and that leaves me with x plus 6. Now, those are my apples, remember, as I say, so I can almost draw up my x plus 6 here, and then think, well, to get minus 2x, I need a minus 2 here, and just double check that that does give me minus 12. So now those are my apples. I've got 5x minus 2 of them. And that's my answer. Double checking, 5x squared, 30x minus 2x is 28x, and negative 12 for my lasts. Now, if I'd done it this way, the factorization would look a little bit different. I'd bring x out the front here, and I'd have 5x minus 2. Now these are my apples. So if I draw up my 5x minus 2 over here, I can see that I need positive 6 out the front to give me the 30x minus 12. Now I'm going to have the x plus 6 first, and then the 5x minus 2, which is exactly the same, they're just around the other way. Now the cross method can be quicker or it can be slower, depending on the type of question and whether you're a little bit lucky with using your trial and error. After you've used it for a while, you can get better with the trial and error part so that you can often spot the answer much quicker. So the first thing we do is we draw up a cross, and we're going to multiply things along the lines of that cross. The first thing we do is we put factors of our firsts in there. So with 3, I've got a prime number there. The only factors of 3 are 3 and 1. So I'm going to have 3x and x, and it doesn't make any difference which one you put where. Basically what I'm saying is that the 3x and the x are going to be my firsts. Now I've got to consider factors of my lasts. With our other method that we just looked at, remember we multiplied these two numbers together? With the cross method you don't need to do that. You just consider factors of the lasts and you put them here. And then you multiply along the lines of the cross to see if you can generate this middle term by adding together the two terms that you make. So 5 is pretty simple too because it's prime. The only factors I've got are 5 and 1. Now if I put the 5 up here and the 1 here, multiplying 5 by x I get 5x, and 1 by 3 I get x, I get 3x. But 5x and 3x can't add up to 16x. So clearly it's not the right way round. So I need to try it the other way. Put the 1 there and the 5 there. Now I've got 15x here and 1x there. And 15 and 1 can build 16x. I just need to add them together. So I can tell with just a tiny bit of adjustment how to put that. Now, if you were just blindly using trial and error on a question like this, you might do what I did and put the 1 here first and then the 5. But once you're looking at this method for a while, you'll realize, well, hold on, if I've got 5 and 1 and I want to get 16x, that's quite a lot of x's, I'm going to need to generate a big number. So you quickly see that you're going to need to put the big number with the big number to generate that sort of number. So it is trial and error, but you can get better at it the more you use it. Now that you've found the partners that you need to make that middle term, these are now your brackets. And if these numbers are both positive, then basically those are your sets of brackets, 3x plus 1 and x plus 5, and you're done. Now, at the end, always check that it works. 3x squared, 15x plus x is 16x, and we've got 5 as the lasts. So yes, it does work. Now, this question has a lot more choices because 6 has more factors. We can either have 6x and x, or we could have 2x and 3x. And then on the other side, we can have 1 and 6, or 2 and 3, and they can be around either way. So this combination has 4 possibilities, and that one has 4. So there's sort of 8 possibilities to try. Now, you might be kind of unlucky and try all 8 before you find the last one is the one, or you might stumble upon it on your first try. So with a question like this, using the cross method, be prepared for a little bit of trial and error before you find the right answer. So let's give this a go. With 6x and x, let's try, say, 2 and 3. 2x, 18. That's not going to give us 5. And remembering that we want one of these to be negative, so basically we need to multiply along our lines and take one term away from the other. Swapping them around isn't really going to help here. I'm going to have 3 and 12. That doesn't help me get 5. Putting a 6 and a 1, I've got 6x and 6x. That doesn't work. And 1 and 6, 36 and 1. That's nowhere near. So clearly none of those worked. Must be 2x and 3x. So trying things, if we have 3 and 2, that will give me 9x and 4x. Aha! 9 and 4 can be used to make negative 5. How do we do it? We're going to need positive 4 minus 9. So positive 4 means that this 4x needs to be plus 4x. So this needs to be a positive 2. And that means that the 3 will be negative. So I've got what I think is my answer. You're never fully sure of it until you write it out and check it. 6x squared for my firsts, that's good. And then I've got 4x squared minus 9x, 4x minus 9x, that's minus 5x, so that's good. And then negative 6, so yes, sure enough, it works.